As mentioned in the last video, there's one more topic I want to cover related to asynchronous programming before we get back to adding new API routes to the Task Manager app, and that is AsyncAwait. Now, I've been working with JavaScript for over a decade, and I remember when all of the features I now take for granted first came out. Things like promises, arrow functions, and others were super exciting and definitely changed how I wrote code. In my opinion, out of all of those new features we've gotten in JavaScript over the years, none is a bigger improvement to the language than AsyncAwait. AsyncAwait makes it so easy to work with our asynchronous promise-based code, writing code that looks more synchronous than asynchronous. Now, the good news is that AsyncAwait is not a whole new thing. It's not like we're going from callbacks to promises to AsyncAwait. AsyncAwait is merely a small set of tools that makes it easy to work with promises. So we're still going to be using the same old promise methods we've used before. Nothing's going to change there. The only thing that's going to change is how we manage our code when we have a lot of asynchronous things going on. AsyncAwait is going to play a major role in the Task Manager application. We'll be using it in every single route handler. So I want to take time and make sure we understand what's going on before we focus on integrating it into existing code. So to start, once again, with a new syntax, we're going to create a new file in that playground directory in the Node course folder. I'm reserving this other playground folder in the Task Manager directory for playground type files that require a database connection like this one here. But to kick things off, we're going to start without worrying about connecting to a database. We'll start with simple, dummy asynchronous tasks. Let's go ahead and get started by closing all open editors, and we're going to switch over to that playground directory, and we're going to add one more file to the list. That's going to be number 9, which I can call async-await, which is the name of the feature we'll be exploring. And then down below in the terminal, I'm going to shut things down and navigate over to that directory as well, like we've done plenty of times before. Now let's go ahead and get started with AsyncAwait and see what it can do for us. To get started, we're going to create the simplest function possible. I'm going to create a constant, doWork, and we're going to set up the value as an arrow function. Now, for this arrow function, for the moment, we're not going to accept any parameters, and we're not even going to do anything. We're going to have an empty function body. Down below, we're going to go ahead and call this function, printing its return value to the terminal. Right here, we'll use console.log to print something. What do I want to print? I want to print whatever comes back from calling doWork. So I'm taking that return value and passing it to console.log. Now, what do we know about JavaScript functions? We know that if we don't explicitly return something from the function, undefined is implicitly returned. So if I was to run the program, I would expect to see undefined printing. Let's go ahead and do just that. I'm going to save the script. Down below, I'm going to run it. Node 9 AsyncAwait.js. Now, when I do so, we're going to get exactly what we expected. I have undefined printing. Now, the reason I'm doing this is because what we're about to do is use AsyncAwait. The first part of the feature is async. This allows us to create an async function, and in that function, we can use the await feature. Now, this will all make sense once we have a more complete example. To start, essentially what we need to do is mark a function as an async function. And this is done by adding the async keyword right before the function declaration. So right here, I have the same old function I had just moments ago. The only thing I've done is I've added async right up front. Now, with this simple change, we're actually also changing the behavior of our program. We're no longer going to get undefined printing in the terminal. Let's go ahead and rerun the script and see what we get. I'm going to rerun the script, and what do I get? I no longer get undefined like I was getting before. Instead, what I can see is that doWork is returning a promise, and that promise has been fulfilled with the value undefined. So this is the first important thing to note about async functions. Async functions always return a promise. That promise is fulfilled with the value you, the developer, choose to return from the function. Let's go ahead and clarify that. Right now, we're seeing the promise get fulfilled with undefined because that's what we're returning. By not explicitly returning anything, undefined is implicitly returned. Let's go ahead and explicitly return something. I'm going to return a string with my name, Andrew. Now we're going to save this script and we're going to rerun things once again. Now we have changed the return value, but I mentioned that async functions always return a promise. So the return value of do work is not a string. It's not this string right here. Instead, it's a promise that gets fulfilled with this string. So down below, we rerun the script from the terminal, and that's exactly what I see. The return value from do work is a promise that has been fulfilled with the string Andrew. Now, since we are getting a promise back from do work, we can actually use then and catch, our promise methods, instead of just taking the promise and dumping it to the console. So I'm going to remove this console.log statement, and I'll replace it with a call to do work, exactly like we had before. Then I'll set up a then call to run some code when the promise is fulfilled, and right here I'll get access to the result. Now in this case, the result is whatever value is returned from do work. So right here, console.log, printing inside of quotes the string result followed by the result variable. So I'm printing it twice, once as a label for what I'm seeing, and then once as the actual value. And we can also set up a catch call. So down below, a call to catch. We're going to set up a function that gets an error. And right here, we'll do the same thing. Let's go ahead and use the correct syntax for the arrow function though. Perfect. And now we'll use console.log. I'll print the string E followed by the actual error. Now, if we run this program, since the promise does indeed fulfill with this value, I would expect to see this code run, and I would expect to get my result. I'm going to save this script, rerun things from the terminal down below, and that's exactly what we get. Now, how do we ever get catch to run? Well, if we throw an error from our async function, that's going to be the same as rejecting the promise that comes back from the async function. So when I return a value, we're fulfilling that promise with the value. We just saw that right here. When I throw an error, we're rejecting the promise with that error. So throw, new, error, and we can pick whatever message we like. Something went wrong. Perfect. Now that we have our throw statement in place, let's go ahead and actually run the program one more time. From the terminal down below, I would expect that my catch function runs, and that is exactly what happens. If I scroll up, I can see I got my little E string, which comes from right here. Then I have the entire error object printing out down below. So there we go. This is the basic structure of an asynchronous function. The question is, why is this useful? What's the other half to the feature that actually allows us to manage our asynchronous tasks with ease? This brings us to the other half of AsyncAwait, which is the await operator. Now, the await operator can only be used in async functions, and now that we have an async function in place, we're ready to talk about await. Remember, the whole point of AsyncAwait is to make it easier to work with asynchronous promise-based code, so let's bring one of our dummy promise functions into the mix. We don't have to recreate it from scratch. Let's go ahead and just copy it from our previous playground script. Right here, we have a function that adds up to numbers after 2 seconds. I'm going to take that function in its entirety, and I'm going to copy it over to our AsyncAwait playground file without changing a single thing about it. And this is done intentionally. When working with AsyncAwait, you don't have to change how your promises function internally. All you do is change how you work with them. For us, that means that Mongoose doesn't need to rewrite the library in order for us to use AsyncAwait. Mongoose supports promises, so as a consumer of those promises, we can use AsyncAwait if we wanted to. Down below, let's see how await is actually going to help us. So inside of do work, we're going to work with add, calling it a few different times. Now, if we weren't using AsyncAwait, I know exactly how I could call add a couple of times, adding up some numbers because we did that a few videos ago. In that promises file, we have that down below. I call add, adding on my first then method. I provide the callback where I return the another promise right here, adding up more numbers, and I get that result down below. That's not what it's going to look like with AsyncAwait. We're going to remove the need for all of those callback functions. So what we get access to in async is the await operator. The await operator gets used with a promise. We can get a promise because add returns a promise. So right here, I'm going to call add to use await with a promise, and I'll go ahead and add up a couple of numbers. I'm going to add up the number 1 with the number 99. Now the sum is 100, but the question is, where do I get access to that data? If I wasn't using async and await, I would add on a then method call, provide my callback function, and I'd get access to the data inside of there. With async and await, it looks as if add is a standard synchronous function. We actually can create a variable right here to get access to the value that the promise is fulfilled with. So in this case, yes, we still have to wait those 2 seconds. The advantage is syntactical. Right here, it's a lot easier to reason about and parse this code than it is the code we have in the other file. Now from here, I can go ahead and return that sum, which is exactly what I'm going to do. Then we'll go ahead and run the program down below. I'm going to clear the terminal output just to clean things up a little bit, and I'll rerun the script by using the up arrow twice and enter. And when I do so, I wait my 2 seconds, I get my result 100 back. So we can see right here that we're able to use code that looks synchronous to perform asynchronous tasks. Now we're only doing a single asynchronous thing right here, so it might be hard to see the advantage. Let's go ahead and switch this function up a little bit. I'm going to remove the return to sum, and we're going to add up more numbers. So I'm going to create const sum2 right here. I'll get the value from using await with another call to add. I'll add up that first sum 100 with the number 50, and this would be 150. Then I could create sum3, going through that process once again, adding up sum2, which is 150, with the number 3, which would bring me to a total of 153. So now I have sum3, and I could go ahead and return that, returning sum3. Now, in this case, we are doing 3 asynchronous things, and they all take 2 seconds, so when I rerun the program, we still have to wait those 6 seconds. Using async and await doesn't make things faster, it just makes things easier to work with. Right here, I get 153 printing. So we wait the 2 seconds to get 100. Then we wait on the next line to get the 150 value. And then finally, we wait for 153. So here, all of our code runs in order, even though asynchronous things are indeed happening behind the scenes. Now, in this case, we have code right here that is much simpler than the promise chaining code we had over here. Promise chaining, while useful, can cause problems, and it's a bit easy to misunderstand what's going on. We have a lot of different functions and return values, and when we return something that impacts what happens further down the chain, this can get us into some confusing situations. AsyncAwait was added to help fight that off. Right here, it's pretty easy to see what's going on once you understand what async and await actually do. Another big problem with promise chaining is that it's difficult to have all of the values in the same scope. So what do I mean by that? Well, right here we have our first sum. Then down below in this function, we have access to the second sum. What if I wanted to have access to both of those sums at the same time to do something, like save them to a database or send them to the user? There's no easy way to do that. What we would have to do is create variables in the parent scope and then reassign them in here, and it turns into a mess really quickly. With AsyncAwait, there's no need to worry about any of that. I have access to all of the individual results in the exact same scope, my async function, allowing for a lot of flexibility. The last thing we need to discuss before we can actually use AsyncAwait in the real world is what happens if one of these promises rejects instead of fulfills. Now, our add call up above always calls resolve. Let's go ahead and switch it up to call reject sometimes. We're going to say that we can only add up positive numbers. If either of your numbers are negative, we'll call reject instead. So right here, if we're going to see if A is less than 0, then we'll use the logical OR operator to see if B is less than 0. So if either of them is less than 0, whether it's just one or whether it's both, this code is going to run. I'm going to use return to stop the function execution so resolve doesn't get called, and I'm going to use reject to provide the error. I'll say something like numbers must be non-negative. Perfect. So now we have a call to reject in place. Now the program in its current state is going to work exactly as it did before, and to prove that, I'll rerun it. We wait our 6 seconds, all of the numbers are positive, so we get our result printing from this line right here. Now let's go ahead and make one of these numbers negative. What I'm going to do is make our last call to add provide -3 instead of +3. Now what's going to happen? Well, things aren't going to crash right away because remember, when using AsyncAwait, things happen one at a time. So we wait our 2 seconds here and everything's fine. Then we wait our 2 seconds here and everything's good. Then we wait our 2 seconds here and we get that error. So after 6 seconds, we're going to see that a problem occurred. I'll rerun the program down below to prove that's exactly what happens. So we're waiting the same amount of time we were waiting before because the error occurs at the very end, and then I get my error message printing. Now, if that happened earlier on, like in our first call to add, we would see the error sooner. If this promise rejects, then none of the code down below is going to run. It's going to skip right to the catch call down here. That's why we're seeing E show up from line 23 in our program. So right here with -99 in the first add call, I'll go ahead and rerun things. Now we still have to wait those initial 2 seconds, then we get the error message in place. There's no need to even run the other code because something went wrong before that code had a chance to run. That's where we're going to stop for this one. Now I know we spent a lot of time exploring the basic syntax, but AsyncAwait is going to play such a critical role in our task manager application, so I want to make sure it got the time it deserved. In the next video, we'll start to integrate this with our Mongoose method calls. I'm excited to get to that, so let's go ahead and jump right in. And once again, there will be a challenge where you're going to have to use AsyncAwait on your own.